Hi, this is Bronwyn, and today we're going to look at what we do when we have variables in our exponents. I just want to recap some exponent vocabulary to make sure that we're talking about the same thing. This whole number we call a power, with this part being the base and this part here being the exponent. So the big number is the base and the little number is the exponent. What this means is we have 3, our base, times 3 times 3 times 3 times 3. So our base is times itself 5 times the number exponent time. All right, so if we have a question where we have our exponent as a variable, that means that that's our unknown. We don't know how many we have, but we can still simplify it. So for this example, we have to think back to our other exponent laws, and we know when we're multiplying that we can add our exponents. So our variables are going to stay in our exponent. Our base is the same, so that's the only way we can combine them. And our 5 stays the same, and we end up with just having A plus B as our exponent. We can't simplify that any further. We don't have any like terms, so we can't simplify that. So then we're just done. We're finished simplifying. I know it kind of seems useless, but at some point it might be helpful. Most likely right now we're just practicing the skill. Okay, let's look at another example. So here we have, again, we have the same base, so we can use our exponent laws. So we know that 10 is our base, so that's going to stay the same. And our exponent is going to be 2t. Because we're dividing, we're going to subtract our exponents. 2t, take away 5t. And that we can then simplify further because these are like terms, they're both t. So 10 is our base. 2t, take away 5t is going to be negative 3t. And then we can either leave that as a negative exponent or we can convert it into a positive exponent depending on what's useful. And that's going to turn into 1 over 10 to the exponent 3t if we want to have a positive exponent. If you're unsure about what to do with negative exponents, I have another video, so check that one out as well to help. And so now we're done. It's simplified as much as we can. We can't simplify it any further, so we are good to go. All right, and let's look at one more. All right, so here we have 13 as our base, so it's the same. So we can combine, we can use our laws. We've got lots of going on here. So we can do this in 2 ways. I'm going to do it like this, 13, and I'm going to subtract because I'm dividing. I'm going to do inside my brackets first. So I have x take away y because I'm subtracting, and this is all still to the exponent z. And then I can simplify that further. And I'm going to say, okay, so I'm going to have to multiply everything that's my exponent by z. That's what the power of a power law is. So 13 stays the same, my base stays the same, and now I'm going to have x. If I multiply x by z, I get xz. Take away, multiply y by z, yz. And there we go. That is as simplified as it can get. These are not like terms, so we can't combine them, so we are good to go. You can also do this question. Make a copy of it. Another way we can do it. So if we wanted to, we could multiply the z into my exponent first. So in that case, we would do 13 as my base. It's staying the same. And then I'm going to do my x times z first. And then with the power of the power rule, every exponent, every base needs to be multiplied by your exponent. So then 13 is going to have y z as my exponent. And then if I want to do division, I do 13 and I subtract my exponents because I'm dividing. And so xz, take away yz. And you see that they're the same. So you can go either direction, whichever makes more sense and feels simpler for you. You decide. But you're going to end up with the same thing either way. All right, hope that helps.